All right, today we're going to work on differentiation problems, and we'll just do a bunch of different examples. First, let's review the various notations. Various notations that mean finding the derivative. So if we're using f of x, then f prime of x means derivative. If you're using y equals, then dy dx. Actually, this should be a t, because this means the derivative of y with respect, on the bottom, with respect to t. And if we're just using y, we can call it y prime, or we can simply say the derivative with respect to r of this function equals something. So these are the various ways you can see derivatives written. Now, let's talk about some rules that you probably already know, but anytime we have a constant multiplying a function, that constant can come right out in front when you take the derivative and just take the derivative of the function itself. So for example, the derivative with respect to x of 5x to the fourth, I can pull that 5 right out in front and then take the derivative with respect to x of x to the fourth. Using the power rule, that becomes, that comes down in front, 4x to the third. Still have this constant 5, I multiply it together to get 20x to the third. The same thing here. I want to take the derivative with respect to x, of negative x. There we go. Of negative x. All right, well that really means negative 1 times x. So that negative 1 constant right here is going to come out in front. So negative 1 times the derivative of x itself is 1. Negative 1 times 1 is negative 1. Now that one, pretty soon you do that and you don't even think about it. But it's something to keep in mind when we're trying to decide what to do with a constant. All right, here's some things we've already learned. Besides the power rule, we know that the derivative of e to the x is simply e to the x. The derivative of a, some other constant besides e, raised to the x, equals a to the x times the natural log of a. And this is just a number, isn't it? Right. Then you said you're starting to learn the derivative of sine is cosine, the derivative of cosine is negative sine, and the derivative of tangent is secant squared. We'll get to the other 3 trig functions later. Other things to remember, and we worked with this before, if we have a position function that we're going to call s, well, the first derivative of the position function is the velocity, and the second derivative of that position function is the acceleration. So as an example, if I had a position function that equaled 4 cosine t, the velocity equation would be the derivative of that position equation with respect to t, which would be, 4 stays there, the derivative of cosine is negative sine, so you have negative 4 sine t. The acceleration then is the second derivative. So I take a derivative of the first derivative to get the second derivative, and I end up with negative 4 cosine t. So we may see some problems coming up like that, but that's something to keep in mind, that we have position, usually you'll see it as s of t. These are all functions of time, right? So then the first derivative of position is the velocity, and the second derivative of position is the acceleration. Let's do some examples. This takes into account the power rule and the trig function. So f prime of this is the derivative of this first chunk, which is 6x, minus the derivative of cosine. I have the 2, and then I'm going to say the derivative of cosine is what? Negative sine. Right, so if we simplify that, 6x plus 2 sine x. All right, here's another derivative. Here we need to use the product rule. Let's refresh on the product rule. If you have some function, I'll call it h of x, and it's a product of f of x times g of x, the first derivative is the derivative of f times g plus f times the derivative of g. So we're going to call this one f and this one g. But I like to write f as x to the 1/2. So this is what we'll start with. So the derivative of f, 1/2 x to the negative 1/2 times g plus f times the derivative of g. The derivative of sine is cosine. Now let's see how we could simplify that. We have this 1/2. This x to the 1/2 can come into the denominator. Then we have this sine x plus, rewrite that. There should be our answer. All right, so that's our product rule. Now here again, we're going to use a product rule where sine of theta is f of theta, cosine of theta is g of theta. So the derivative of sine, cosine theta times g, right, plus sine times the derivative of cosine, which is negative sine. Right, so cosine theta times cosine theta is cosine squared theta. Notice this becomes a minus sine squared theta. All right? Let's look at these. These are incorporating the chain rule, where we have, here I'm going to rewrite f of x here as x squared plus 1 to the 1/2. So I'm going to do the derivative of the outside and then the derivative of the inside function, because we have a function in there. So this outside, if I bring the 1/2, I'm going to have 1/2 this quantity to the negative 1/2, that's the power rule, times the derivative of the inside, which is simply 2x. All right, if we put that together, if we simplify, we'll end up with x on the top and the square root of x squared plus 1 on the bottom. That would be our derivative. All right, here, the second one, we'll have the power rule. We'll do the outside and then the inside. So the outside is taking some quantity to the 4th. So the derivative is 4 times that quantity to the 3rd times the derivative of the inside quantity, which will be 6x squared. So I could simplify this to say 24x squared times 2x to the 3rd plus 5. So I think that would be the final derivative answer there. All right, this last one here says e to the square root of x. Now I always like to write it e, I say x to the 1/2. So the derivative of the big function, which is basically e to the x, is simply e to the x. So that comes down, and then it's going to be multiplied by the derivative of this exponent, which is 1/2 x to the negative 1/2, right? So if I rewrite this, I can put the square root back in. I'll have e raised to the square root of x over 2 times the square root of x. All right, let's try a few more. And these will also be the quotient rules too. This will be the quotient rule. Let's remember what the quotient rule says. If you have a quotient f of x over g of x, the derivative is f prime g minus f g prime over g squared. So we're going to do a mixture of these things here. So the first one says the derivative of 1 is 0, isn't it? So this first term is really 0, doesn't matter what g is, minus 1 times the derivative of this, which is 2x, over this g squared. Now guess what? For the most part, you'll leave it just like that, and that's your answer. So that was the quotient rule, wasn't it? Right, this one here will be the product rule, but also incorporating the chain rule, because we have some inside functions going on there. So our product rule is f prime g plus f g prime. So we're going to start with the derivative of e to the minus 2t. Well, it's e to the minus 2t times the derivative of this up here, which is negative 2. Now times g, right, plus e to the minus 2t times the derivative of cosine of 4t. Well, the derivative of cosine is negative sine of 4t, right? And then we have to do the derivative of the inside, which is 4. So let's see if there's any way for us to write this a little minus 2e to the minus 2t cosine of 4t minus 4e to the minus 2t sine of 4t. Not sure. If need be, we could factor this out, but I think we don't have to get any more simplified than that. So look at this one. Y equals 2 raised to the sine pi x. So the outside function is 2 to the x, right? So that becomes, derivative becomes 2 sine pi x times the natural log of 2, right, times the derivative of this inside. So the derivative of sine is cosine pi x, and then the derivative of this inside function is pi. So let's move the natural log, let's say pi, natural log of 2 times 2 to the sine pi x times cosine of pi x. That would be our derivative. All right? Let's see if we can finish this last one. We have a product rule and a chain rule. So if this is f of x and this is g of x, and the product rule says f prime g plus f g prime. So we're going to do f prime. Well, power rule, 4 times this quantity raised to the third times the derivative of the inside, which is just 2, right, times g, as it is, plus f times the derivative of g. Now this is a power rule. We've got to bring a 5, x squared plus x plus 1 to the 4th, derivative of the inside, which is 2x plus 1. I'm really not sure. I guess we could put these two together and say 8 times 2x minus 3 to the 3rd, x squared plus x plus 1 to the 5th, plus 5, 2x minus 3 to the 4th, x squared plus x plus 1 to the 4th, 2x plus 1. So we used the power rule, we used the product rule, we used the quotient rule, we used the chain rule, and we used some trig functions and e to the x and a to the x. So we'll get to more, but take a look at this and see if you can repeat these problems. Okay.